Hello and welcome back to compiler programming. We ended up the last video with being able to parse a module that contains a couple of functions instead of just one, which required to do some changes around how the function parsing is done and separating the definition from the function itself. So in order to progress further, I think the next really important milestone would be to support actually calling the function. So I'm going to change this slightly and say that this is going to be a proxy and this is going to call 1. And then we need to change slightly our test. In particular, we need to remove all of this stuff and change this to proxy, proxy, and proxy. Now, if I try to build this, of course it will be fine, but if I try to run it, it will probably tell us that, yeah, we were not able to reduce expression to one element. So we didn't know what to do with this one stuff. And this is the next thing that we're gonna do, which should be pretty straightforward. I think so. We have this stuff that deals with the expression, token match expression. So this thing here, and this stuff is this is where we're gonna implement our matching of function calls. Before we do though, I'm considering that I want to unify how match module and this stuff actually works, which means I want to take this stuff out and use a different setup slightly. Okay, this looks good. Now I can remove this stuff and I can do token star plus is token peak match of state 1, and then we have this stuff. So basically I can actually copy these things around and do it like so. Instead of arrow we have a plus, and we say if not plus continue. Then we have left hand side and right hand side. This is going to be slightly different. So we say token star LHS token is token peak match of states 0 and token, but we actually are not interested in any of the fields, so here is going to be 0. Here is the same thing. Probably we can make this more efficient. Actually, we can, because I can use token peak instead of token peak match, right? Yeah. So I should be actually just using token peak here, which would be faster and nicer to look at. So 0 and 2, and now I can do this stuff. Probably till here. LHS token and RHS token. Yeah, actually we can even probably fold these things in, because the expectation is that if we found a plus, it needs to be valid. Okay, now we have some problems over here, but we can pretty easily fix that stuff by just moving these things up, I think. And then we remove this stuff. Okay, expression parent, yeah, this is gonna be plus. Source is actually long term, we do need to do something here, so maybe I should add a to do and say that should encompass the whole sub expression. And what I'm talking about here is when we are doing tokenization, imagine that we have x plus 42. So individual tokens, they sort of, okay, let me make it 4x's. So individual tokens will have like the source specified. So this would be kind of one token, right? This would be another one. I'll put like numbers. So this is one token, this is another one, and this is the third one. But if we want to know what is the expression, this should be just the whole thing here, right? It should be everything included. So when we highlight that something is not correct, we should be highlighting everything once we get to that point. But for now, we don't have error output in a nice way anyway, so that's just something for the future. Okay, plus is not the function. Oh yeah, that is a bit of a problem. We should call this plus token because we also have plus that is a function. Token, that's fine. Yeah, it was called root here. I guess it is token, and token. Parent is not a member of value. That is correct. It should be plus token. This is token and token. Okay, let's check. We still should have that error, but at least the first function should work. Yeah, and that is mostly fine, except it looks like now we are trying to access something outside of array bounds, which is not great. So let me actually figure out where it is happening. This is a debugger. We're gonna try to run. And where are you failing? Yeah, that's happening. Bounce check. Okay, yeah, this is fine. I actually messed this up. This should be I. And then we are replacing I plus 1 and I plus 3. That's not really great. I wish I figured out how to do it better way, but for now, I'm not sure what would be a good API for doing this stuff. Okay, we are back to our error, which is great. So let's add it to get indexed and continue. So this is our problem now, but we can basically just copy this stuff and say, this is gonna be our new thing. Let's do that. I'm not even sure we need to create a new token mature state, to be honest, but let's do that for now, just to be safe. And the rest is pretty much exactly the same as it was, except we are matching on different things. What we will be matching on is slightly interesting because let's just think about what the function looks like. We have a parent-sized stuff on the right side, so that's the easy part. The question is, what is on the left side? And what is on the left side is either this stuff, right? So there needs to be an identifier, or there needs to be an expression, which is also a parenthesized stuff. So we could also have something like this should technically also work because we are looking up this ID. This ID is gonna get us to this function, and then we have an expression which we don't know yet how to parse, by the way, so we don't support like parenthesized expressions. And then we would end up with the same thing again, and we call it. So the point is, on the left-hand side, it's a bit tricky to figure out what we need to match against. But I think we can start with just the ID and parents, and if I figure out that we need more stuff, then we do that. Or alternatively, we figure out that we actually need to change the precedence of this. I don't know. Let's see how it works out. Maybe this whole matching way how I'm doing is not gonna work out at all, and then we're gonna go with something more traditional like peg parsing or something. But for now, I think it's pretty neat, so let's continue down this rabbit hole. Anyhow, here we are looking forward, and we want to match parent, right? So if next one is not parent, then we are not even interested. So maybe let's add something like this. Match function calls. So here is args token. Okay. Now we want to have so what would be the case in which we don't want, yeah. So we say token star maybe target is this, if maybe target type is token type ID, or maybe target type is token type parent, then we do something, and otherwise we will not do anything. So maybe let's actually invert this logic and say if not, so stuff like this, if it's not ID and it is not a parent, then we just do continue like we did above. That is pretty straightforward. Now we have the right thing, and we are ready to force the value. So we say force value, maybe target a scope. And just to remind you, what that will do is it will look up identifiers if it needs to, or parse literals, but identifiers is our main thing. So we have a target, and we are ready to make a call, except that we haven't yet parsed arguments, but that is fine for now. So what I will do is I will say that how do I want to do args array value putter args is token match args, and actually have it already there. Yeah, we have match argument. We say match call arguments, and we will pass in the scope, I guess. Yeah, we'll pass in our args token and then scope. I we might need the builder as well, actually, because arguments might do arbitrary things. So let's just say we also need a builder. Okay, we'll copy this stuff. It needs to return array value putter, and then we say return dynamic make array of this stuff. Fix me, implement this. And actually I can do even better. I can say assert that token children dynamic array length of token children is 0. That would be fine. It's the array make, not other way around. Match expression, yeah, it needs to be match call arguments. Okay, making some progress. Token type paren. That's good. We need this stuff. Okay, so this is fine. We need to remove next element, so this is what it does. I think I can actually do this. It's slightly easier. Yeah. Okay, that looks good to me. We have the target, we have the array of values, so we are ready to make a call. In reality, this array is obviously empty, but that is fine for now. Let me bring up this stuff, and I think I want function call function value. Yikes. This thing is expecting a call with variable number of arguments, so I need to create a thing that will accept an array version. Value array, and it's basically the same thing as it was before, except it's is looking like this. Arguments. Okay, and we just take this stuff, we put it over here, and here we say return call function value array and pass builder to call and target. Okay, that looks fine to me, but apparently I got an extra comma. Good. So this file looks fine, and now I should be able to use this function, except I need to add it over here as well. So this is now like this, like this, like this, this, and array value through arguments. Okay, this is ready to be used. Let's do just that. Yeah. So value star result is call function value array, and we pass what we need to be passing, which is builder to call an argument. That is not a problem. Builder, target, and args. It's builder underscore in our case. And now we are ready to create this stuff. I want to extract this stuff and say something like token value. Make this was too much, and I need the plus. So we allocate the token, we get the stuff. So we can say token star parent or original. Yep. And value star result. Okay, just so that we don't have to do it all over and over again. Okay, token value make, that sounds good. I can use it over here. Token star results token is token value make of args token, and we need to pass in result. Okay, that's at least built. I also want to make use of this stuff here. So let me take this result token and just say that it's plus token and result. Okay, that looks fine. Let's see how terribly we crash right now. Okay, assertion failed, a result value on line 400. Force value. Okay. So we ran into something much earlier than I thought we will, but this is, I guess, as good time as any to talk about this. So what's going on? What's going on is that at the time where we try to execute the body of this function, we actually have no idea that this what one is. And this is an interesting kind of topic altogether, right? Because even if we were able to fully run this line first and only then run this line, so like we would actually define the thing one, and here it would find it, everything would be fine. But I also want to make this work. Like, there should be no reason why you can't define things out of order. So this means that we need to do something about that. And this is where things get very tricky. They would be a bit less tricky if I wasn't trying to do these weird things with how I'm doing the parsing, because what you could do then is you could like start parsing from left to right, realize that this is a definition, and just not do anything with this stuff to the right of it. So you just store it somewhere and you don't do it. Then you do the same thing here. Then you end the file. And at that time, when you end the file, you go through all of the definitions. So you realize you had these two definitions and you start processing them. You try to process this one. You realize that you need the other one. So you process the other one and then you're done. This is sort of the simpler version of this. It's still a bit cumbersome in case of what I'm trying to do. It is a bit more complicated than that as well, because we are not even interpreting the line from left to right. We have, remember the first that we try to reduce this into a function, and only then this definition happens, which is sort of backwards. And maybe that will come to bite us in other places as well, but for now, to stick with it, we basically have to do the same thing. And the way I'm gonna deal with it is to introduce even more token types. When in doubt, just add more stuff. So here's the idea how this is gonna work. I'm gonna introduce token type function or lazy function definition. And what that is, it will store all the stuff that the function wants, but it will not actually parse the body. And that means that we could use things in the body that are not yet available there. So this stuff should then technically work. Now, we have a similar problem with types, or we'll have a similar problem with types eventually, where maybe we'll define a custom type only after the function. So that's also something to consider. But for now, that's not an issue, and in reality, it doesn't really matter. What matters is that for this lazy function value, we will need to add another thing. So type Devstruct token lazy function definition. And this thing is going to have, basically, I'm just going to store the tokens. I'm not even going to do anything with them. I'm going to say token star args. I'm going to say token star return types and token star body. Okay. Yeah, we don't know what the hell is a token, which is fine. We can do type Devstruct token. Okay, and then I can do this. That's fine. And this lazy function definition can be one of the union, and we can say lazy function definition. Okay. So here we again need to say that we have no idea what it is. Apparently I messed up something real bad. Okay. Okay. I'm not sure what happened before that. But now that means we need to change some things around. And again, what I will do is I will comment out this tests just for now, so that we can verify that all other things work. And right now they will, because we haven't actually changed anything. But it's good to start with a passing state. And now we are ready to do things. So what are we going to do? Now that I'm thinking about that, it is entirely possible that we don't need to store it in the token, but rather in the scope. Let me think about this. Or maybe we actually will need to do both eventually. Anyhow, so this is what we were doing before, and now we will do this stuff. So I'll take this, I will put it here, and I will say that we're allocating a token, but token type is now lazy function definition, and the rest stays basically the same. Yeah. And this can go, it can stay here, that's fine. But all of this stuff is not what we want to do right away. So we're gonna take this, out, and with this stuff, we're also gonna remove these things, and we'll have something like, actually we need to move it to force value, I guess. Let me think about this for a second. So yeah, we actually need to do it in two steps. So in the first step, we are just collapsing it into a single token, and then the next step, we will either change how our scope works to make it return not just values, but something else as well, or we add another value type that will be that lazy function definition as well. For now, I'm just gonna say something like token force function, or force lazy function definition. So I guess this will need a program. Yeah. And what else does it need? Our returns definitely value. Let's get a bunch of errors and start dealing with them. Okay, yeah. It definitely wants our lazy function definition, and I will even do this. So yeah, that is fine. And then we pass that. So lazy function definition star. Okay. So we get our definition. We will extract the tokens out of there. So we say args is args. We also have return types. And we have body. Okay. That is fine. Body result. Token match expression is undefined because I moved this way too high up. this should be here. Actually, this type is no longer even necessary. Okay. Yep. And here we say lazy function definition. This is pretty straightforward. Args, return types is return types, and the same thing for the body. Okay. And we are not returning a value here. That is very easy. We just return value. Okay. That's good, but now everything is really, really broken because, well, I will show you what happens. Basically, when we try to force a value, we'll get something that we don't know. Yeah. So this happens over here. We right now end up here. And this is because this stuff, where are you? Yeah, here, it tries to force this value, and it can't. Now that I'm thinking about it, we might not want to force any of the values at all when we do this kind of definition, because if we want to be able to do something like, let me try to do some pseudocode. So imagine that I want to alias a type, something like typedef in C. So I want to do typedef my S64, but at that point imagine that x64 itself is defined, or my struct, like this, my struct other struct, right? So I'm just aliasing kind of my struct to other struct, but then I want to define other struct over here. So I want to do typedef struct blah blah other struct. In C, that is not okay because because you need to predefine values. But it would be nice if it would be okay, and that means that if we are translating to our syntax, that will be something like my struct is other struct, right? And that just means that if I do this, should also work, whatever that would mean. And all of that just to say that whatever is on the right side should stick to be a lazy evaluated thing. So we are capturing, saying that there needs to be something, and eventually we will try to figure out what that is, but we are not going to do it at this particular moment in time. So all of this to say that we need to change what scope is. And this is going to be a bit of a complicated change, I guess, because its scope was defined in value, I think. Yeah, we move this stuff over here, but we should move it elsewhere. And here we should just say typedef struct scope. And then we're going to move it to here. And scope is going to be something very different now. Or not very, but different. And what's going to be different is that it will be a map from the slice, not to pointer to the value, but to a special scope entry. And that scope entry, in turn, will be as following. It will have a scope entry type, and it will be a pointer to the value, or it will be a token star. If it is a token star, that means that we haven't validated it, and if it is value, it means we have. So type def enum we have scope entry type value or lazy. Okay. We have a bunch of errors. Let's see where they are. They are inside of value C. That is fine. We can move this stuff to here as well. Now we have even more errors. That's because here it needs to be like this. Okay, we are getting better. Yes, now our problem is of course that we were expecting to return a value star star. Now we're gonna be returning a scope entry pointer. So that is like scope entry, and should I return it by value? I guess it's fine, it's small enough. But then I can't indicate failure. No, so this is like this. This would be basically the same, except, well, I think I want to create two separate ones, scope define value and scope define lazy. So that's just gonna be easier to deal with, so we don't have to create scope entries ourselves. We can do it here. Scope entry type is, let's do it on multiple lines. Type is scope entry type value. That is correct, and value is value. And here is basically the same, except type is lazy and token is token. Okay. Too many yikes. Map that. I guess it doesn't like this. Well, fine. Scope entry is this stuff. Are you happy now? Let's do the same thing here. And entry. Okay. Scope lookup. That is fine. We do scope entry, just entry. And now we say, yes, assert of entry. And then it's going to be entry value. Entry value. That's fine. Yeah, this one is good to go. Eventually, we need to deal with lazy stuff here as well. So for now, I'll just do assert entry type is scope, and entry type value. Actually, yes. Okay. Looks good. Scope lookup. Yeah. And this is the funky part of all of this. So we took a big detour, but now we are getting back on the point of actually making this work. We have an entry, but now we need to look up it in the regular scope and do it like this. We have an entry, and we check that it actually does exist. And afterwards, we are gonna do this if entry let me think about this for a moment. Yeah, actually, if entry lazy, or entry type is scope entry type, well, let's start with value, doesn't matter. Or even better, I will do a switch here, so if I introduce more entry types, it will actually be angry at me. Okay. If it is a value, that is very easy. We just do what we were doing before. If it isn't a value, we recursively call its call token force value. Yeah, that sounds good to me. We say token force value of entry token and scope. Does this compile? Incompatible types. Yeah, this should actually be entry value. Okay. It's good that I did that, because apparently copy paste is the root of all evil. Okay, this is fine. Scope define. Here it is value. So that's good. And here is where it's gonna be scope defined lazy. And we just do, actually this should be token pick. Okay. Token star value. We assert that we have it. And yeah, this looks good. These errors are probably coming from yeah, so I think I want to do stuff like this. Scope lookup value star scope lookup. No. Let's not be lazy. So we get this stuff. We say scope entry star entry is this. Yep. And we check that entry type is scope entry type value. And then we are ready to say that entry value is this. Okay, now it's just a matter of copy pasting this into other tests. And we are ready to rock. Okay. Scope lookup. Scope level 2, global value. Value is global. Is this fine? Okay, more errors. Well, now we have an issue with this stuff. So maybe we do want to yeah, let's create one. So we do scope. Actually, we do value star scope lookup force. And it gets the same things. It gets an entry that is just forward into scope lookup. But then it does this stuff. So it checks that entry actually does exist. And then it will do the same thing as what we were doing in token force value. In fact, I actually want to move that logic there. So I can say here result value is scope lookup force of token and scope. And now I can just do this stuff. And I will need to forward declare this function here. So this goes like this. And now we are good. Okay, this file is fine. And over here, I can just do this. And this should be much better. Okay, what did I mess up? And this should be scope and token source. Okay, that is fine. Default, actually, assert not reached. It's really sad that in C there is still no return attribute that you can say that, oh, actually, this thing is never supposed to return, which you usually annotate your assertions with. Okay, that was a lot of changes. I expect that I made some mistakes. So let's run the test and see where we exploding. We are exploding at line 508, which is over here. Yeah, actually that is fine. That is perfectly okay, because we need to say else if token type is token type lazy function definition. Then we need to say return. What's this called? Token force lazy function definition. And some forward declarations. And we can call this thing. Except we don't have a program, which is a bit of an issue, but not much. We can just pass the program here because we usually have it handy. Which means that we will need to pass the program to lookup, which is not that great. How should I do this? I guess it uses the scope to look up types. And also it's necessary for the function builder. How to do this? Well, here's what I'm gonna do. What I'm gonna do is I'm going to fold the program into lazy definition because it should not exist outside of the program, and I can just say program. Obviously that will create its own things where I now say token lazy function definition. Okay, that is fine. We need to extract the program here. And we still need to put the program there because we were not doing it here. So we can say program is program. Okay, let's see if this is any better. Okay, we are exploding pretty terribly, and now this is happening inside of value.c. So what is that all about? And oh yeah, so let's look precision. I have an idea what it is, but let's verify what is actually happening. So value as function, yeah, it cannot find it inside of the test. Function spec main and yeah, so it explodes over here. Let's just go through the whole thing, and I'm more interested what happens over here. So let's do the thing there, and I'm pressing the wrong button. Let's go inside. So we are trying to look up foo, that is fine. It is of type lazy, so we go into token force value. We go here. It is a lazy function definition, as I would expect. We go inside, and this is where I'm interested in stuff. So we do have all the things. The program is correct one, args, return types, body, everything is fine. Yeah. So now we actually need to do it like this. We need to look it up, I think, before ending the program. Let's see if that makes any difference whatsoever, but that's what I'm thinking. Okay, so it does make a difference, yeah. I guess we will need to change how program end works. We'll need to create ones that are specific to programs that are being parsed out of the files, because what needs to happen is, if we are planning to use a function, that function needs to be forced. And in reality, for executables, we'll just say, okay, this is our main function, and forcing main function will force all other functions, so that is fine. And the only thing sorry, I'm just thinking that actually this stuff is gonna go terribly wrong even after we fix it. But let's see that. I will not run ahead of the train. So this needs to go now here, and this needs to go over here. Fine. Okay, all this works just okay. But this stuff I'm expecting is not gonna be very good. Although it might be. It might be. Let's see. Okay. We need to say lookup force, and again, this needs to happen before. Ooh, this was unexpected. I guess it works. So what I was worried about, just to explain, I was worried about what would happen is we will start doing that, and then in the middle of writing out the instructions for this function, we will start writing the instructions for this one. But first of all, here it doesn't really matter because there are none. But secondly, I remember that actually inside of function builder, like this push instruction thing, it's I think it's somewhere at the very top. Push instruction internal, yeah. So this stuff, it just pushes it into the builder. So this was actually a very good thing to do. That means that we are not dependent on the, like, we can push into two builders at the same time, and it's perfectly fine. So this is good. And in the end, this is just perfect. This means that we can put our functions out of order, and everything is just great. I think that was quite enough for today. I'm pretty happy with the progress, and hopefully see you next time with the next episode.